If we have the graph or the function y is equal to x squared minus 1 over x squared plus 3x plus 2, and I say graph it, labeling xy intercepts, asymptotes, all the fun stuff, what do? That would be silence, people listening on YouTube. Factor. Say it with conviction.
Factor.
There we go. All right, so we factor it. Top is x plus 1, x minus 1, x plus 2, x plus 1. Okay? What cancels? Okay, what does that mean? Those are the PODs. So we're left with x minus 1 over x plus 2. We have a POD on the factor that cancels, so x is equal to -1. Yes, I don't know why I blanked on that. So whatever makes those factors 0, so -1. How do I find the y value of that POD? Put it into what's remaining. -1 minus 1 is -2. -1 plus 2 is 1. So it's -2, right? So y is equal to -2. So POD at -1 and -2. All right. Vertical asymptote. -2. How do you find the verticals? Whatever makes the denominator 0 after you've canceled the POD, or the POD, I guess, yeah. So x is equal to -2. Horizontal. Sorry? Look at the degrees. If they're the same, the leading coefficients. Now, you can either look at the degrees on the factored form or the original. It doesn't matter. You'll get the same answer. What is it? The degrees are 2, but what are the leading coefficients? 1, so the horizontal asymptote is y is equal to 1. We should do x-intercepts and y-intercepts. X-intercepts, what's the only thing you need to look at? Numerator after you factored it, right? So what's the x-intercept? X equals 1, whatever makes this 0. So x is equal to 1. Y-intercept is when x is 0. Again, you can either look at the original or you can look at the factored form, but really all you're looking at is the, go away, the constant terms there. So -1/2, or if you looked at this one, -1/2. All right, now we can sketch it. Vertical at -2, horizontal at 1. POD at -1, -2. 2, which is, I don't know. There. X-intercept at 1. Y-intercept at -1/2. What else do we do? What do we have to check now? The other side of the vertical asymptote, right? To see where the other part of the graph is. Any number that's to the left of -2, so if you put -3 in, if I do it to the factored form, so if I just go x is equal to -3, I'm going to get -3 minus 1 over -3 plus 2, -4 over -1, which is 4. So that means at -3, we have a y value of 4, which is somewhere up there. All I care about is that it's above the horizontal asymptote. And then the graph looks like that. Is that okay? Do you want one to go backwards? There you go. Is that it? Sorry. So what do you do? Well, let's just talk it through. What do you do if you're trying to figure out the equation of a graph? What do you mark? Where do the vertical asymptotes go? In the denominator, right? So -3 and 2 is going to give me x plus 3, x minus 2 in the denominator. Your POD, so it's at 4. You have to have that top and bottom because that's how you get a POD, a factor that cancels. So that's this bit. Your x-intercepts are only in the numerator. There they are right there. And then what's the last thing you have to check? The HA, the horizontal asymptote, which is at -2. If you look at the degree of the top, it's 3. The degree of the bottom is 3. So you know it's the leading coefficients. But it would be 1 over 1. So we just throw in a -2 at the beginning. And that's it. Okay? And then don't multiply it out. Just leave it like that. Do we feel okay with that? Okay. On the retest tomorrow, your 2 short answer questions, the rest of it's multiple choice, will be one of graph something given an equation, and the other one will be generate the equation. Okay? All right. Polynomial time. It's been a while since we did this. Okay. So when we were doing polynomial graphs, we were looking at the degree, and I'll put LC for leading coefficient. First graph, what's the degree, even or odd? First two graphs, even or odd? Odd. If the arms go in different directions, you know it's odd. So that's odd, odd. If the arms are in the same direction, it's an even. Okay, leading coefficient. What arm do you need to look at for the leading coefficient? The right arm. If the right arm is up, the leading coefficient is positive. If it's down, it's negative. All right. Let's do. Okay. We'll focus on the graphs and then we'll talk about the dividing stuff. So. Okay. If I say P of X is equal to. Hang on. I'll sketch the graph first. It's a better way to do it. Oh. Okay. Here's our graph. Not a very good graph. What's POI? Point of inflection. Okay. So I say figure out the leading coefficient of this graph. So I just started it over here. So we write it in factored form. We put a C value because that's going to be the leading coefficient that we have to find out. The x plus 2 is this right here, the first x-intercept. What do I do for the second x-intercept at 3? What's the factored? X minus 3 all squared. Nice. And it's squared because it bounces off. What do you call the bounce? Tangent. Right? You call it bounce, but it's actually called a tangent, right? And then the POI, point of inflection, has a what do you call the little degrees on each factor? Multiplicities. So what's the multiplicity of the POI? 3. We're always going to assume lowest multiplicity, but it's just any odd multiplicity is a POI except for 1, and any even multiplicity is a tangent. So x minus 5 cubed. Okay. All right. What do we do to solve for the leading coefficient? Once again, YouTube, silence. Plug in your x and y values, right? Don't plug in the intercepts, right? Because if you don't plug in the x-intercepts, this is an actual what? How can that be 1, 4? Oh, it's because I drew it wrong. I put the dot in the wrong spot. Let's erase the dot. See if I can. Oh, that didn't. Oh, there we go. Go like this. There we go. There, 1, 4. Sorry. So if there's a point that's indicated, plug in your x, y's. Solve for c. And then it's just algebra. So 4 is equal to c. Can I make the assumption you all know how to do algebra? Good. So we get c is equal to Negative 1 over 192. It's a weird number, but whatever. Okay, so then you get your C value. You need to look at it and just ask yourself, does it make sense? Really, all you're looking at is the sign. Is it positive or negative? The fact that it's negative, does that make sense? Why? Because the right arm, well, both arms are pointing down, but the right arm in particular is pointing down. Okay, so you know it has to be negative. If you got a positive answer, you'd be like, that doesn't really look right. Okay, that's graphing. We feel okay with graphing? Now, factoring polynomials. Okay. I'm not going to ask you to factor a polynomial on the test. We've done enough of that. Okay. What I will ask you are possible factors, i.e., how do you decide what numbers to try? Yeah, so you look at the last number. What are the factors of 5 or negative 5? Plus minus 1, plus minus 5, right? And you divide them by the factors of the leading coefficient, which is plus minus 1, plus minus 3. So I'm going to go through this. 1 over 1 is 1, so that's plus minus 1. 1 over 3 is a third. 5 over 1 is 5. And 5 over 3 is... Now, how do you write those in the binomial factor form? Yes. So we go x plus minus 1. Now, how do I write 1/3? I could write x plus minus a third, but what should I write? 3x plus minus 1. I love that everybody's remembering this stuff. X plus minus 5, and the last one will be 3x plus minus 5. Those are your binomial factors. How do you know which one is a factor? You try them. But there's one key thing when you try them that you need to look at. What's 0? The remainder is 0. If r equals 0, then it is a factor. Okay, there's 2 ways to find r. We're just going to do a quick synthetic division because that will rear its awesome head in calculus. If we're going to try, I don't know, doesn't matter. Let's do x plus 1. So that's the factor we're going to try. What number goes in front of the division, synthetic division? We're only going to do synthetic. Negative 1, because it's what makes it 0. What do you put in here? The coefficients, right? And you have to make sure that they goes down in order. So are we missing anything? We're missing the cube. So what do I put in as a placeholder? 0. So I get 3, 0, 2, 1, negative 5. How do we do synthetic division? Drop it down. Multiply by this number here. I get negative 3. They're always adding. So I get negative 3. Multiply by negative 1. I get 3. 5. Negative 5. Negative 4. 4. Negative 1. That's your remainder. So is this a factor? No. But if I said to write it TQ plus R. Remember, grade in math, we're math 12, that's what we're in. It's Dairy Queen plus remainder. And when we get to calculus, we'll write it slightly differently because that has an advantage for certain things. What's D stand for? Divisor. What does that mean? In what thing is the divisor up there? X plus 1 is the divisor. It's what you're dividing by. So what's Q? Quotient. How do you find the quotient from the numbers we have here? Okay, you're saying it's these? It's everything but the remainder, right? Now, the only thing you have to think about is we're dividing a fourth degree by a linear. So what's the degree of the quotient? 3. It goes down by 1, right? So the quotient is 3x cubed minus 3x squared plus 5x minus 4. Tack on the minus 1 and you're done. Okay, so this is our quotient. There's a divisor and there's a remainder. There is a way to find the remainder without doing synthetic division. It's called the remainder theorem. Do you remember how to do that? You take this value, this negative 1, what makes the factor 0, and just plug it into the original. So if you go p of negative 1, so I go 3 negative 1 to the 4, 2 times negative 1 squared, plus negative 1 minus 5. That's 3 times 1. That's 1. Minus 1 minus 5 is minus 6. 3 plus 2 is 5. Minus 6 is negative 1. It gives you the remainder. But that's all it gives you. Okay? So you can use the remainder theorem if they're asking you what is the remainder. That's the question. But if they want you to do anything else, and you're going to have to synthetically divide anyway, it's usually a little faster to just go straight to synthetic division. Okay? Polynomials in a nutshell. How do we feel? Good? Okay. We got Geo and Trig, right? Was that all I was doing? What do you want first, Trig or Geo? Wow, that was pretty definitive. Geometric. All right. What's a geometric series? Once again, YouTube, silence. What's a geometric series? What's an arithmetic series? When you're adding, what's a geometric? There we go. You're multiplying. So if I have 2, 4, 8, 16, dot, 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 dot. We'll make this nice and easy. Let's go through the terms. What does A represent? First term, yes. Sometimes called T1, but I just prefer T1. I prefer A. A little more prestigious. It's the way I am. What does R represent? Ooh, common ratio. How do you find it? You divide the term in front by the term behind. So it's the common ratio. So if I go 4 divided by 2, I get 2. 8 divided by 4 is 2. 16 divided by 8 is 2. It should be the same all the way along. If it changes, then it's not a geometric. But we don't worry about those. Okay, so the formulas. You get the formulas because you get a formula sheet. This is the general term. Tn is equal to ARn minus 1. No, I write the formulas different. Then there is the sum, which is A r to the n minus 1 over r minus 1. And there's also another sum formula, which is I forget how I wrote it in the book. Who's got a book? It's like, I have it written differently here. What's the second sum formula? Is it RL minus A over R minus 1? Yeah, okay. So I'll write Tn minus 1 over R minus 1. That is the last term. I usually write it, I like it this way. RL minus 1 over R minus 1. L represents the last term. Okay? So that's the big hint in these formulas. Use this one when you know what the last term is, because it has the last term, or you're trying to find the last term. Use this one when you don't know the last term. So let's just practice. Oh, there's one other formula for sum. This one, and I remember S infinity. A over 1 minus R. Remember that? No. Yes. When do you use this one? Well, obviously when you're summing to infinity. But when you sum to infinity, only certain sequences will actually give you a number. Others spin out of control, and the sum just gets bigger and bigger. But some converge on a number. I just used the word. How do you know if it's convergent? If you know the last term? Well, yeah, but that's if you know the last term, it's not an infinite series. An infinite series means you keep adding forever. But some will actually converge to a number and others spin out of control. So how do you know if something's convergent? Yeah, but what is the R value? Yes. So R is less than 1. It'll be greater than 0, i.e. it's a proper fraction. Okay? Then you can sum because it's convergent. If it is not a proper fraction or it's bigger than 1, the sum's going to get bigger and bigger and bigger and bigger. So for example, this series that I put up here, 2, 4, 8, 16, if I try to sum that to infinity, it's going to be infinity. It's going to keep getting bigger and bigger. But if I have the series 2, a half, a quarter, ... like that, that's, put a 1 in there. There we go. Then it's getting smaller and smaller. That will be convergent because the R value is a half. All right? Sorry? It doesn't have to get closer to 0. It'll just get closer to a certain number. Some will get closer to 0. Well, you can sum something to 0. Not as infinite series. I think I'm holding that back. All right. Sigma notation. Now, k is equal to 1 to 10 of 2k. So what does this mean? So you start with k is equal to 1. It means this. 2 to the 1 plus, and then you keep putting in the numbers until you reach the upper limit, which is 10. So 2 squared, 2 cubed, 2 to the 4, 2 to the 5, up to 2 to the 10. The sigma term means sum. Add them all together. Okay? If I asked for the number of terms here, how do you figure out the number of terms? Hello? Hey? Well, he doesn't come to school very often. No, he's not. Sorry, that was a yeah, right. Sorry, I wasn't clear. He was early, and he's kind of yeah. All right, all right. You're welcome. Bye. How do you find the number of terms? Upper minus lower plus 1. 10 minus 1 plus what is 10 terms. And this one, you could go through, figure out all these numbers and add them up, or what could you do? If I said actually sum this. Look at the numbers. First term is 2. Second term is 4. Third term is 8. What's the R value? 2. So R is equal to 2. A is 2. Do we know the last term? Yeah. So 2 to the, I don't know, what's 2 to the 10? What is it? 1024. So T10 is 1024, that? Okay. So we can use this formula if we want, because we know the last term. So the sum will be R, which is 2. Last term is 1024 minus 1 over R minus 1. 2048 minus 1 is 2047. 2047, because you're divided by 1. Okay, so if you actually get asked to sum a sigma series, write out the first few terms to figure out your A and your R value, and then figure out the number of terms. You can calculate the last term if you want, or we could have used this formula right here. You know the first term, you know the number of terms, which is n, by doing this. You can plug it in that formula and you get the same thing. Any other questions? Any questions about Geo? Any other type of question you want me to go over? Yeah. Sorry? I can't hear what you're saying.
Do we have a question like going from like your exactly equation to the system equation?
No. Okay. That's it. All right. Trig 1, which will be fairly short because it overlaps with Trig 2. I will leave the graphs on the board. Okay? So you don't need to memorize the graphs. Trig number 1. All right. I will leave special triangles up. You should know rads to degrees. You should know how to do that. Do we know how to convert between rads and degrees? We've done it a million times. If you're going rads to degrees, you multiply by 180 over pi, right? Because you want the pi's to cancel. 108? What am I even writing here? 180 over pi. There we go. And if you go on the other way, you multiply by pi. Pi over 180. Okay. This formula will be, I think, is this on your sheet? A is equal to r theta? I think it is. Okay. I will ask you to use this formula. What do we use it for? These types of questions. R is this. A is the arc length. Theta is this. What is the only trick? It's not even a trick. What is the only requirement in using this formula? Theta has to be rads. I don't care if you give me the decimal or you give me like pi over 3, pi over 4, whatever. If you give me the decimal, that doesn't matter. As long as it's in rads. If you try to do it in degrees, you're going to get it wrong. Okay? The only other thing you really need to know for trig 1 is you have this, these are your general formulas. A sine B x minus C plus D. Remember this? Why are you? Same for cosine. Tan, we're not going to, oh yeah, we should worry about tan. Cos, tan, whatever, I'm not going to write it. Okay. How do you find A from a graph? What does A represent, actually? Let's start with that. A vertical stretch, if you're transforming it. From a sinusoidal graph, it represents amplitude, right? You're right, but it's the amplitude. So if I have a graph, like this is 10. Okay, the scale's way off, but I don't care. -7. How do I find the amplitude of that graph? It's max minus min divided by 2. So in this case, 10 minus -7. I should have picked better numbers. Whatever. 17 over 2. We'll just leave it as that. 8 would have been better. But. Okay, that's how you find amplitude from a graph. The D value. That's the midline or the vertical displacement. What's the formula to find the D value? It's max plus min. You don't get these formulas. So you need to remember them. So 10 plus -7 over 2 is 3 over 2. 1.5. So there's your midline. I'm not asking you to generate the equation of a graph, given a graph. I won't ask you that. I will ask you to find A, D. The only other thing would be the period. What's formula for period for sine and cosine? 2 pi or 360 over b, right? So you just, so you can use the period to find the b value, right? Period is the distance between any points that repeat, exactly. So if this is, 2 and this is 10, the period would be 8 because it's this distance here. That's the period. So then you would just go 8 is equal to 2 pi over b. You solve for b, so b is 2 pi over 8, which is pi over 4. Is that okay? So sine and cosine are straightforward. What's the only trick with tan? Period is 180 over b. So this is sine and cos for a tan graph. Period is pi or 180 over b. That's pretty much it. I'm not going to ask you a Ferris wheel question on the final or on the retest. Remember how to solve these? Add sugar to coffee, sine x is equal to a half or negative half, what quadrant you're in. We did a ton of that in trig 2 as well. Okay? That's it. There are trig 2 questions on this test, but they're all multiple choice. 16 multiple choice, 9 marks short answer out of 25. The short answer is all rational functions, like graphing and generating the equation. Okay? I believe that's it.